Friends, study with the Pal Engineering and General Geology Parvin Singh. तो इन चैप्टर्स इंजीनियरिंग प्रॉपर्टी ऑफ रॉक में हम लोग ट्रांसफर स्ट्रेंथ पे हैं. तो it is defined as the capacity of a stone to withstand bendings, loads, and such loads are only rarely involved in situations where stones are commonly used. But when a stone is intended for use as a beams or as a lintel, its transverse strength is determined as a modulus of a rupture using the following relationship: R is equal to 3WL by 2BD square. Where R is modulus of ruptures and W is the load at which sample break. L length, B is the width, and D is the thickness of the test specimen. Transverse strength is determined practically by loading transversely a bar shaped test specimen, generally 20 by 8 centimeters, and is supported at end from below. The load at which the stones break ruptures is taken as a W, from which R can be calculated. It has been found that in stone, transfer strength is generally 1/10th to 1/20th of their compressive strength values. Shear strength of a stone is also not commonly determined except when the stone is to be used as a column. It has been observed that in important building stones, the shear strength lies between 70 to 140 kg per centimeter square. Porosity: the size, shape, and degree of packings of the components, crystals, or grains in a rock give rise to its porosity. Numerically, it is expressed as the ratio between the total volumes of the pore space and the total volume of the rock samples, and is expressed commonly in percentage terms. And porosity range values for few common types of building stones are: granite 0.1 to 0.5%, sandstone 5 to 25%, basalt 0.1 to 1%, and limestone 5 to 20%, marble 0.5 to 2.0%, quartzite 0.1 to 0.5%. Low porosity is caused by interlocking crystals, angular grains of different size and unconformally distributed cementing materials in the rocks. Conversely, the rocks will be highly porous if composed of sphericals or rounded grains, example sandstone, or if the cementing material is distributed unevenly, or is of a poor cementing value. Absorption values define the capacity of stones to absorb moisture when immersed in water for 72 per hours until saturation. It is generally expressed in percentage terms of original dry weight of the stones. Samples of a cub shape are made from the stone and dried at 100 degrees Celsius and till they attain a constant weight and W's, and these samples are immersed in water and are weighed after the regular intervals of 8 to 12 hours till they attain a constant weight S, which indicates their saturations with the absorbed water. The absorption value, which indicate the pore value or porosity, is given by the relationship absorption value is equal to S minus W upon W into 100, where W and S give the dry and saturated weight respectively for the specimens being tested. Sandstone and limestone may show in some varieties as high absorption value as 10% or more. Selection of such highly porous varieties of stones for use in building construction, especially in moist situations, would be greatly objectionable. Presence of water within the pores and not only definitely decrease the strength of the stones but also make them vulnerable to disintegrations due to frost actions in cold humid climate. Density: It is defined as the weight per unit volumes of a sandstone. In this case stones, but in the case of stones, the concept of the unit volumes has to be clearly understood. A cubic centimeter of a stone shall not always be made up 100% of solid matter. It may contain 1% to 25% of pores space porosity, which may be empty, partially is filled, or wholly is filled with water. Accordingly, three types of density values may be differentiated in the case of rock as follows. Dry density, it is the weight per unit volumes of an absolutely oven and dried rocks. Obviously, it includes the volume of the pore space present in the rocks. Bulk density, it is the density of rocks with the natural moisture contained. It is assumed that in such cases all the pore space are not filled with water. Saturated density, it is the density of rock fully saturated with water. In most engineering calculations, it is the bulk density that is taken into consideration. Bulk density value is in grams per cubic centimeter. For some common building stones are granite 2.7, basalt 2.9, sandstone 2.6, and limestone 2.2 to 2.6. The knowledge of density values of stone help in making an estimate of approximate strength values of the stones, and also in calculating the loads implied in stone masonries at different level. Abrasive resistance, it is more qualitative than quantitative property and may be broadly defined as the resistance which a stones offer to rubbing sections of one kind or another. This quality acquires considerable importance when a stone is intended to be used in a situations where rubbings by natural or artificial causes may become a routine. Thus, stones used in paving along roads, in floorings in buildings, and linings in tunnels, or facing stone in buildings where sand loaded window and blow quite often are all exposed to rubbing sections. Hence their resistance to abrasions should better to know before use. Mineralogical composition of stones play a great role in resistance to abrasions. A stone made up of the same minerals and will wear unconformably when soft. Example, limestones and marbles. It may not wear at all if made up of hard minerals. Example, quartzite and sandstone. But another stone like granite having an appealing appearance but made up of minerals of different hardness. Feldspar and quartz may get abraded unevenly. It may present a bed pit appearance after a few years of its use in areas where sandstones are quite frequent. Abrasion resistance of a stone is commonly determined in civil engineering laboratory using Dory abrasions testing machines. It consists of revolving steel disc provided at the top with two metallic funnels shaped projections placed at diametrically opposite ends. One projection is for holding a properly prepared cylindrical stone sample of a dried weight and proper dimensions, 2.5 centimeter height to 2.5 centimeter diameter. The other projections is used for feeding standard sand at a standard rate that causes the stones to veer at the base during rotation of the disc and thus losing some weight in the process. After a fixed number of revolutions, generally 1000, the stone sample is taken out, revived. The loss in weight is a measure of abrasive resistance of the stone. Commonly, it is first calculated in percentage terms of original dry weight of the sample, and then a coefficient of wear is obtained from the following relationship. coefficient of wear 40 by percent loss in the weight. The same value of a coefficient of wear is 20 when the loss in the weight of stones after 1000 revolutions of the disc is only 2%. Frost and fire resistance. Many building stone so quick disintegrations events used in the situation where either frost forming climate prevails in first case or intensive heating is involved in the second case, and frost causes disintegration by expressions of water on freezings within the pores of rocks during winter. It is melting during summers, and the pores process getting repeated year after year. This is called frost actions, as already is explained in the weatherings of rock. Porous varieties of limestone and sandstones often show very poor frost resistance. Fire resistance is especially determined when a stone is intended for use around stove, heating places, and in the walls of kilns or furnaces. Ironically, many otherwise sound building stones like granites and others coarse grained igneous rocks are poor in fire resistance. These may become unsuitable for use in the heat extensive situation. Their poor fire resistance is due to their multi-mineral composition. Different minerals explain at different rate on getting heated. The unequal expansions becomes the cause of internal stress within the body of the rocks, leading ultimately to its disintegration. Similarly, some rocks, though made up primarily of one minerals, may also disintegrate when subjected to heating conditions. Limestones, for example, are made up of calcite that decomposes under temperature beyond 750 degrees Celsius. Only compact and massive sandstone and quartzite will prove durable around heating places. Thank you. Please support it.